Here I have a question. Does A divide B? There's a few different ways that I can phrase this question. Does A divide B, written out in words? Is A a factor of B? And is it true that B equals A times K for some integer K? And it's this last one that I'm actually going to use to analyze this type of statement. So let's say, for example, we want to know if 6 divides 15. So what my question would be here, or what I would look to determine, is it true that 15 is equal to 6 times some value k, where k is an integer? Well, I'll solve this equation for k, divide both sides by 16, and I can do some simplifying. I've got a 3 that goes into both of those. So that gives me k is equal to 5 halves. But what we said originally was k is an integer. Right? So k is not allowed to equal 5 halves. So the answer to this is no. Does 6 divide 15? No, it does not. And that's the end of that one. Now let's take a look at another one. Here I'm asking, does 8 divide 2? And this will trick a lot of students, because what they'll do is they'll look at this and they'll say 8 divided by 2. Sure, that gives me 4, and there's no problem. But it's not asking you to do an operation here. The question is does 8 divide 2? And by divide, we mean divide evenly. So of course it does not, because we can't say that 2 is equal to 8 times k for some integer k. Solve for k. Just like in the last problem, we get k equals a fraction, 1 over 4. So the answer to this one is no as well. In this one, it asks if 14 divides 42. So what I'll do is I'll take 42 equals 14 times k, and just determine, is there a value of k for which this works? And when I divide both sides by 14, I get k equals 3. So in this case, yes, 14 does divide 42. And what is the answer? The answer is the yes. It's not the 3. We weren't asked for the 3 here. It helped me determine my answer, but it is not itself the answer. The answer is yes, because it's a yes-no question. Now let's take a look at a little bit different type of problem involving divisibility. Here I'm asked, if n is equal to the quantity 2k minus 1, does 4 divide n cubed plus 3? And we're to assume that k is an integer. All right, so we know that k is an integer and n is equal to 2k minus 1. So if n is 2k minus 1, then n cubed would be the cube of 2k minus 1. And there's a plus 3 on the end there, so n cubed plus 3 is equal to 2k minus 1 cubed plus 3. Now, I'm going to have to FOIL this out, so that gives me 2k minus 1 times another 2k minus 1 times another 2k minus 1. And of course there's a plus 3 on the end. So I'll take my first two 2k minus 1s and say, well then that equals 4k squared. Outer is minus 2k, inner is a minus 2k, and the last is a plus 1. And then that's still multiplied by the other 2k minus 1, and then we have the plus 3 on the end. So I'll continue on this problem, distributing the 2k and distributing the -1. You can see how that goes, etc. Okay, so when we finish FOILing this out, what we end up with in discrete math, when we talk about divisibility and dividing things, it's important to understand the difference between talking about divisibility and actually doing the operation of division. So when we say, does A divide B, and we use the notation here with A, a vertical line, and B, then this means, does A divide B, and we mean evenly, so does A go into B a whole number of times, or an integer number of times, right, because it could be negative. We can also say, is A a factor of B? And another way of saying this is B equal to A times K for some integer K? And this is very often what you want to use in order to determine if A divides B. So let's take a look at a couple of examples. Example 1 asks, does 6 divide 15? So for me to determine this, what I'll do is I'll say, is 15 equal to 6 times k for some integer k? And when I solve for k, what I see is that k is equal to 15 over 6, which is 5 over 2, and that is not an integer. So that means that 6 does not divide 15. So my answer to that would be a no. Next I look, does 8 divide 2? This is a classic example of one that students will get wrong because they know it has to do with divisibility and they look at it as 8 divided by 2 and they say, well, that comes out to an integer, and so they want to answer yes to this. But when you actually set it up as we've been doing, then I'm taking 2, setting that equal to 8 times k, and immediately it's obvious that no, there is no integer k, that when you multiply it by 8 you get the integer 2. So k is equal to 1/4, k is not an integer, and so this is also a no. Now how about, does 5 divide 20? Same thing, set it up, 20 equals 5 times k. Now when I divide, k equals 4. 4 is an integer, so k is an integer, so we're all good, and that's a yes. Now let's look at some problems with variables in them. This problem asks, if n is equal to 2k minus 1, does 4 divide n cubed plus 3? In order to solve this type of problem, what I'm going to do is figure out what n cubed plus 3 is in terms of k. So I'll just really use algebra and substitution here. And I'm going to say that n cubed plus 3 equals, well, we know that n is 2k minus 1, so I'll just substitute in the 2k minus 1 here, plus 3. And now I will multiply this out, the 2k minus 1 to the third power. Now there's a couple of ways of doing this. You can use FOIL and then use the distributive property, or you can use the binomial theorem if you remember that. And what that says is that you take the first term to the third power, so that's 2k to the third power, and then I'm going to keep reducing the exponent on my first term, 2k, and increasing the exponent on my second term, which is a minus 1, because I can look at this as plus a negative 1. And I have to put in my coefficients also from the binomial theorem. So we get that from Pascal's triangle. And because we're only going to the third power, it's really easy to get to that third row of Pascal's triangle. So here's the first row, second row, third row. Easy to identify what row it is because you have that number there. And so it's 1331. So this is really a 1 times 2k to the third power. And then I'm going to go plus, and now my coefficient is 3 for the second term. And 2k is now to the second power, and the minus 1 is to the first power. And then I'll take a 3 times 2k to the first power times negative 1 squared, and then plus 1. Well, and now 2k, I don't have any 2k. I could write 2k to the 0 power, not necessary, that just makes it 1, and I have negative 1 to the third power. And then don't forget, there's a plus 3 on the end. Okay. So now let's simplify this, and I get 8k cubed plus, well, I don't want to have a plus, do I? It's going to turn out to be a minus because we have a negative 1 times 3 times 2k squared. So 2k squared gives me 4k squared, and then times 3 is 12k squared times the negative makes it a negative 12k squared. Then we have the negative 1 squared here, so that's just going to be 1. Then it's 2k times a 3, so this is a plus 6k. And then we have negative 1 cubed, which is negative 1 times 1 is just negative 1. And then I have my plus 3 on the end. So I'll just go ahead and combine together that negative 1 and the plus 3. And that gives me a minus 2 here. Okay, so now I've got my expression simplified. So this is n cubed plus 3. And my question is, does 4 divide this quantity? So, oh, that should be a plus 2, shouldn't it? There we go. So either way, what I'm looking for is, can I factor out a 4 here? So can I make this equals 4 times some expression where all of the terms are integers? So I have 4 times 2k cubed minus 3k squared. So it looks good so far, but then we get to the 6k, and I can't do this and get an integer in here. So I would have 6 over 4, which is 3/2 k, not an integer. And then, of course, 2 divided by 4 gives me 1/2. So because these are not integers, the answer is no. And that's my final answer for that.